Hello student, good morning. I am Dr.A.K Sinha, Professor of Chemistry. Today I am going to discuss preparation of some important addition polymers. Last class I have discussed free radical mechanism. Now I am going to discuss preparation of some important addition polymers. In that I will discuss polythene, preparation of polythene. There are two types of polythene. First, low density polythene, and second is high density polythene. Then first I will discuss low density polythene. It is obtained by polymerization of ethene under high pressure of 1000 to 2000 atmospheres, very high, 1000 to 2000 atmospheres at a temperature of 350 Kelvin to 520 Kelvin in the presence of traces of oxygen gas or peroxide initiator. Here peroxide is catalyst. Correct? Last class in mechanism you have seen, you have taken peroxide, this benzoyl peroxide as catalyst, and it has produced two phenyl radical. Then one phenyl radical first has been used, and after that chain propagation started, and second phenyl radical which you got from the benzoyl peroxide, second was used just to terminate the reaction. That is the third reaction, chain terminating step. In that second phenyl radical which you got from the benzoyl peroxide used up in terminating the reaction. That is a terminating step. Correct? One has been used as an initiator, chain initiation step, chain initiator, and second radical was used in terminating. Okay, that I have discussed last class. Here again you are using peroxide as indicator. Temperature is very high, not the pressure is very high, 1000 to 2000 atmosphere. Temperature is 350 to 570 Kelvin, and in presence of dioxide. Dioxygen means oxygen gas, or peroxide, any one. Then here peroxide is used as a catalyst. The low density polythene, that is also called LDP, low density polythene, obtained through the free radical addition and H atom abstraction, has a highly branched structure, and its mechanism will be same. Okay, here ethene you will use, double bond ethene. Same behavior what I discussed last class, same thing will happen. But if you apply the condition of high pressure and temperature, then you will get low density polymer, and it has highly branched structure. That is a characteristic. Low density polythene is chemically inert and tough but flexible and a poor conductor of electricity. Remember, Reaction is as it is, no change at all. Correct? Ethene, last time you have taken ethene double bond. Here also you will use ethene only double bond. And same way, chain initiation step, chain propagation step, chain terminating step will take place. In chain terminating step, what you got propagating step, that will be there, and another also one more phenyl radical was there from the initiator, that also in sidewise that reaction will go, and now we got both radical, one through propagation step, other again second in a similar way will get a chain propagation step, and both this chain propagation step, now it will combine in termination. Okay, reaction will stop. Then here only condition you have to maintain: 1000 to 2000 atmospheric pressure, temperature 350 to 350 Kelvin to 570 Kelvin, and peroxide will be the catalyst. Then that time you will get highly branched structure. Okay, that will be low density polymer. Low density polythene, LDP, low density polythene. Low density polythene is chemically inert and tough but flexible and a poor conductor of electricity. Means electricity can't pass. Electricity will not pass through this polythene, low density polythene. It is a poor conductor of electricity. Hence, it is used in the insulation of electricity carrying wires and manufacture of squeeze bottles, toys, and flexible pipes. These are the application. This low density polythene is used in the insulation of electricity carrying wires. Insulation of electricity carrying wires. You have seen that on the wire one polymers will be there. Cover will be made up of polythene. That polythene is low density polythene. Okay, then it is used in the insulation of electricity carrying wires and manufacture of squeeze bottles, toys, and flexible pipes. Now high density polythene. Again reaction will be the same, only condition you have to maintain. Here it is formed when addition polymerization of ethene. Here also you are ethene you are using. It is formed when addition polymerization of ethene takes place in a hydrocarbon solvent. This is the condition. It takes place in hydrocarbon solvent in the presence of a catalyst such as triethyl ammonium and titanium tetrachloride. That is called Ziegler-Natta catalyst. Here catalyst what you will use? Ziegler-Natta catalyst. N-A-T-T-A. Natta you can tell. Ziegler, Z-I-E-G-L-E-R. Ziegler. Z-I-E-G-L-E-R. Ziegler-Natta catalyst. This is the requirement. Correct? It is formed when addition of polymerization of ethane takes place in a hydrocarbon solvent in the presence of a catalyst such as triethyl ammonium and titanium tetrachloride. This is called Ziegler-Natta catalyst at a temperature of 333 Kelvin. to 343 Kelvin and under a pressure of less pressure 6 to 7 atmospheric pressure, only 6 to 7. Then you will get a high density polythene. High density polythene thus produced consists of linear molecules, and thus a high density due to close packing. You will get here high density due to close packing. They will all will be closed. Then obviously it will be heavy. Correct? In that first case, low density, it was the branched, highly branched structure. That was a low. Density was low. But here it is a close packing. That's why it is high density. It is also chemically inert. Reaction will not take place. It is also chemically inert and more tougher and harder. It is used for manufacturing buckets, dustbins, bottles, pipes, etc. Again I am telling you, it is used for manufacturing buckets, dustbins, bottles, pipes. Here high density polythene is required. Now next I am telling you, that is the polytetrafluoroethane, Teflon, very important polymer. Teflon, that is the polytetrafluoroethane. Okay, polytetrafluoroethane. Here fluorine atom will be there. In ethene, that fluorine will be there. Okay. Then how it is prepared, I am telling you. But here one thing I want to tell you about the Ziegler-Natta catalyst. Actually, this is two scientists are there. First scientist is it is the name of two scientists, Ziegler and Natta. G. Natta of Imperia and Carl Ziegler, second scientist of Germany, were awarded the Nobel Prize for Chemistry in 1963 for development of a Ziegler-Natta catalyst. Sometimes in general competition question is asked. Okay, G. Natta, he belongs to Imperia, and Carl Ziegler of Germany were awarded the Nobel Prize for Chemistry in 1963 for the development of Ziegler-Natta catalyst. Now come for the Teflon. Teflon is manufactured by heating tetrafluoroethane. Here see, Teflon is manufactured by heating tetrafluoroethane with free radical or persulfate catalyst at high pressure. Again I am telling you, Teflon is manufactured by heating tetrafluoroethane with a free radical or persulfate catalyst at high pressure. It is chemically inert and resistant to attack by corrosive reagent. It is used in making oil seals and gaskets, and also used for non-stick surface coated utensils. In kitchen, this utensils you are using, okay, non-stick surface coated utensils. Okay, then here it is used because it has no effect of corrosive reagent, means resistant to attack by corrosive reagent. It has no effect of corrosive reagent. It is chemically inert and resistant to attack by corrosive reagents. Reaction is very simple. CF2, that is called tetrafluoroethene. CF2, CF2. Actually, both H has gone. In ethene, each carbon has two hydrogen and double bond will be there in the middle. But here both hydrogen gone and at its place fluorine is there. At both carbon, fluorine atoms are there in the place of two hydrogen on each carbon. Then this is called tetrafluoroethene. Then n number, n molecule, n number, if you will take CF2, and then you can say this in presence of catalyst at high pressure. This in the presence of catalyst at high pressure. Here catalyst is persulfate. Then CF double bond, CF2 double bond was there, that will convert into single bond. Correct? Now after that another tetrafluoroethene will come. Again it will join, addition reaction. Correct? Because when one bond will break, then both carbon will get one radical. This will happen in the presence of persulfate. Then now second ethene will come, then it will join with the first. Again third will come, then it will join with the second. Again fourth will come, it will join with the third. Like that way it will continue. Hence you can write CF2, only double bond become single bond, and both carbon will be one valency opened for others. Then you can write CF2, single bond CF2 whole N. Down you can write N. This is called Teflon. Teflon. Now next polymer I am going to use, that is a acrylonitrile, polyacrylonitrile. Correct? Polyacrylonitrile. Okay. Here how we will get the addition polymerization. All are addition reaction. Addition polymerization. The addition polymerization of acrylonitrile in presence of a peroxide catalyst. Always you are using peroxide catalyst. Then here the addition of polymerization of acrylonitrile in presence of peroxide catalyst leads to the formation of polyacrylonitrile. Poly only what you have to add, because many acrylonitrile will add. Reaction is simple. Acrylonitrile formula you should know, that ethene formula you know, ethene. Here that in the place of one hydrogen, one CN will join, cyanide ion will join, means one hydrogen will go and one cyanide will join. All things will be as it is, means CS2 double bond. Here also it should be CS2, but one is gone and in its place CN has joined. Correct? Then this is called actually acrylonitrile. Nitrile is due to the CN. Okay. Then if you will take n number of acrylonitrile, then now same way reaction will take place. In presence of peroxide, polymerization reaction will take place. Double bond will become single bond, and that only difference is there. Double bond becomes single bond. All things are same. Both carbon will have one electron. One electron means they have open valency. Both carbon have one electron because bond has broken. Then now again another molecule will come. It will join with first one. Again third one will come. It will join with second one. Fourth one will come. It will join with third one. And fifth one will come. It will join with fourth one. Like that it will continue. It is addition, polymerization. Hence, already that CN is attached to the second carbon. Already I told you. Correct? Then only that polymerization will take place. CN will be in with every time, because it is acryl nitrile you are using. CN is there. Then now you can represent that CH2, CHCN whole N. But both carbon will be opened. And this open valency will go little outside. You can write in bracket CH2 CHCN always open and should go little outside from the bracket, both side. Then this is called polyacrylonitrile. Polyacrylonitrile is used as a substitute for wool in making commercial fibers as Orion or acrylan. Its main use is the substitute for wool. In winter, you are using the wool. You are using the wool cloth, wool. Then that wool is natural. But here, artificially also can be used. Then this polyacrylonitrile is used as substitute for wool in making commercial fibers as Orion or acrylan. Acrylan, ACRYLAN, acrylan. Then this I have discussed low density polythene, high density polythene, and after that I have discussed Teflon, means polytetrafluoroethene, and also I discussed polyacrylonitrile. Now I am going to discuss condensation, polymerization. Okay, condensation, polymerization, or other name is step growth polymerization. Already I have given background for this condensation polymerization, that is also called step growth polymerization. And here what will happen? You know that some molecule will come out like H2O, HCl, HBr, HI, means halide will come out. Sometimes alcohol may also come out during the reaction. Okay, condensation reaction. Then here this pteryline or dacron, whatever you can tell, both are same. I will tell the reaction. Okay. How will you get pteryline or dacron? Dacron sade pteryline cloth, you know. Cloth of dacron and pteryline was common few years back. Okay, then how it is prepared? This is actually polymers. How it is prepared? Then I am telling you. It is prepared from ethylene glycol. Ethylene glycol is called ethene 1,2-diol. Ethene 1,2-diol. Here actually what will happen? That ethene, you know, that is the carbon-carbon double bond. Both carbon has H2, means CH2, double bond. But now you think that one bond broken, then each will get one electron carbon, or you can simply understand from the both carbon one hydrogen gone and one OH joined, both carbon. And now two OH group will be there. Two OH group will be there, means CH2OH, one carbon, other carbon again, CH2OH, and now double bond became single bond. Double bond became single bond, means CH2 OH, CH2OH, that is ethane 1,2-diol. Ethane, this is called ethane 1,2-diol. This is called ethylene glycol, also called dihydric alcohol. Glycerol is called trihydric alcohol. Glycerol or glycerin, both are same. That is a trihydric alcohol. 3 carbons are there, trihydric alcohol. Here 2 carbon is there. It is called dihydric alcohol, also called ethane 1,2-diol, because single bond is there. Correct? Ethane 1,2-diol, and also called ethylene glycol. Question is asked. Ethylene glycol is used as a coolant. Remember, in cold countries, actually this is used. Then ethylene glycol you are using here, and here second molecules you are using, that is the benzene 1,4-dicarboxylic acid. Means with benzene 2 COOH group is attached. One is at ortho position, other is at para position. Correct? Means just opposite. With benzene 2 carboxylic group is attached, one at ortho position, other at para, or 1,4 also you can tell. Hence its name is benzene 1,4-dicarboxylic acid. It is also called terephthalic acid. Okay. Then these 2 molecules you will use here. Both will be in the N number, a small n. N number of ethylene glycol and N number of terephthalic acid, also called benzene 1,4-dicarboxylic acid. Then now reaction is very simple, because ethylene glycol OH is there, both molecules are close. Then ethylene glycol OH is there, and here in benzene 1,4-dicarboxylic acid, COOH, that group, that H from the COOH and OH from the ethylene glycol, both are close. Then you know what will happen? OH will leave by taking its electron as OH negative. Then carbon will become positive, and H from the COOH, that will go as H plus. Then oxygen will get negative. Then this negative oxygen and positive carbon both will join, and whatever you will get product, their name is pteryline or dacron. Means now you will get that this, because both have carbon and oxygen has joined. Then now in benzene first COOH, now only COO will remain, because H has gone. Then that O, one oxygen, first oxygen is attached with carbon, double bond. Correct? And one oxygen, second oxygen is joined with single bond. And that oxygen has joined the positive carbon of the ethylene glycol. Correct? Hence you will get what is remaining. Remaining, actually I told here, both end after now we got a long product. Then ethylene glycol, first carbon, that you can write as open, because in the it can attach with the other molecules of terephthalic acid. Hence you can write opened valence you can write. Okay, just hand will be opened. Then in bracket you can write now that OCH2H, OCH2, again CH2. Correct? This CH2 OH was there, then OH has gone. this has joined with the O. Then OCH2, CH2, O, C double O, benzene ring, C double O. And again you write benzene ring, after that C double O you can write. Why you are writing again C double O? Because again here valence is opened. Because one side of benzoic acid H is leaving, but other side with another phenol. This phenol means here I want to tell you about the ethylene glycol. It can join from the both side. Ethylene glycol has OH. Both side OH is there. Hence terephthalic acid can come join from the both side. You remember, it can join from the both side. That's why you are writing that OCH2CH2 and C double O. C double O is remaining, benzene is there. After that CO you can write. This time OH of terephthalic acid, or you can tell benzene 1,4-dicarboxylic acid. Then now this first carboxylic acid OH will join with H of ethylene glycol. Correct? Then now one time benzene has 2 carboxylic acid. Then one time only H will go, and then C double O will remain. That O will join with carbon. And other side second time OH will go. And from ethylene glycol only H will go. Correct? You remember. C double OH group is there with benzene. Then one time it will lose only H from the COH. And other time in the next C double OH it will lose OH. Then only O will remain. Correct? That's why CO will be remaining. Hence in bracket you can write OCH2, CH2, C double O, benzene ring, again CO only, and open hand. Open hand will be there. And hole will be in bracket you can write outside N down. This is called pteryline or dacron. Okay, pteryline. Now other we can say polymers I am telling you, that is the polyamides. This is also condensation reaction. Okay, condensation polymerisation reaction. Now polyamides. Then here polyamide, you understand, name is polyamides. Here you will use amides. These polymers possessing amide linkage. Are important examples of synthetic fibers and are termed as nylon. Already I have discussed this reaction, nylon 6,6. Okay, same, that is actually comes under the these things, polymerisation, condensation polymerisation of amides. Okay, the general method of preparation consists of condensation polymerization of diamines with dicarboxylic acid. Diamine you will require and dicarboxylic acid you will require, and also of amino acids and their lactams. Okay, these are from amino acids also you can get, from diamine also will get, from amino acids also will get. But when you are using diamines, you should use dicarboxylic acid. When you are using amino acid, then that time you can use lactams. Now nylon 6,6, I am telling you quickly, you will understand, because already once I have explained. It is prepared by the condensation of polymerization of hexamethylene diamine with adipic acid under high pressure and at a high temperature. Adipic acid, that is the CH2 whole 4, both sides COOH will be there, correct? This you have to take in n number, and here you have to use diamine. Here this I told you, hexamethylene diamine you have to use, means CH2 whole 6, both side NH2. Then now that adipic acid and hexamethylene diamine both will come close. Then H2 from NH2, correct? Here NH2, not H from the NH2, and OH from adipic acid will react. It will go as a H2O. That earlier reaction also H2O gone outside. Here also H2O will go outside. COOH is there, that OH and H from NH2. And now same way OH will go as OH minus, carbon will become positive, H is going as H positive, nitrogen will become negative, nitrogen and carbon will join. Then product what you will get, that is the nylon 6,6, correct? You can write very easily. Only that in bracket you write the product in the bracket, repeating unit always you should write in bracket, and whole N you can write down, open end, both one side nitrogen will have open end, open valency, and other side carbon will have open valency. Then already told you nylon 6,6 is used in making sheets, bristles for brushes and in textile industry. Nylon is used as a cloth, sari also. Nylon 6,6 is used in making sheets, bristle for brushes and in textile industry. Only nylon 6. Now second I am telling you nylon, second polymer of polyamides. It is also polyamide. Nylon 6, not 6,6, 6,6, already I told you. But here is only nylon 6. It is obtained by heating caprolactam. You remember, this is new for you. Caprolactam with water at high temperature. Okay, without knowing the caprolactam, you can't make a nylon 6. Okay, caprolactam. Caprolactam, how will you write? Then you can write it easily. Actually, this is the ring. This is the ring of 7 atoms. This ring is of 7 atoms. Out of 7, 5 are carbon and all are attached with single bond. Correct? Then out of 7, 6 are carbon. Correct? Not out of 7, 6 atoms are carbon, 6. And 1 is nitrogen. 7th one is nitrogen. 6 are carbon and 7th is nitrogen. Then it is a ring of 7 atoms. Then 6 are carbon, 1 is nitrogen. Now you see, with nitrogen only 1 hydrogen is attached, all are single bond. But carbon with carbon, oxygen is attached with double bond. When everywhere single bond is there, then obviously carbon has 2 valency, that is joined with oxygen, double bond, CO. Then it is easy to write caprolactam. Caprolactam, 7 atoms members, 7 atoms rings, 6 are carbon, 1 is nitrogen. Nitrogen has 1 hydrogen, and carbon is attached with oxygen with double bond. Then this plus H2O. Then what will happen, I am telling you. Here that 6, actually this only bond will break, all thing will be as it is. Only bond will break. But from where it will break? Then it will break from CO group is there, CO is there, CO and NH. CO or NH, that bond, single bond is there, that bond will break. Then now it will be a straight chain. One end will be NH and other end will be CO, because bond is breaking from NC bond, C and N bond is breaking, correct? Because here temperature you are using high, 533 to 543 Kelvin in the presence of H2O. Then only this bond is breaking, nothing is happening. It will come a straight, one end will be, now it was in ring form, after breaking the bond it will become a straight chain. One end will be NH, other end will be CO. Because bond is broken, then nitrogen will have 1 electron, carbon will have 1 electron. Or you can tell 1 electron both have, means open hand. Simple way. Then now 5 carbon, you will get CH2 whole 5. Because 5 CH2 was there, 6 carbon was there, but it was CO. That's why you can write CH2 whole 5. One side NH, other side CO. N is open hand, carbon is open hand, means 1 valency. Then this is the repeating unit. You can write in bracket, and outside down you write N. This is called nylon 6. Now we will ask, why nylon 6? From where 6 came? Then now you can see CH2 whole 5, then 5 carbon and CO, that C, total 6 carbon. That's why it is called nylon 6. Nylon 6 is used for the manufacture of tire cords, fabrics and ropes. Actually, application you should know, nylon 6 is used for the manufacture of tire cords, TYRE, tire cords, fabrics and ropes. Okay. Then now I have told about the polyamides, and it is these are the example of condensation, polymerization. Then here, why condensation you are understanding? Because H2O is going outside. Now next I am telling you, under polyamides, polyester, name itself is there, polyester. Ester is RCOOR, you know, RCOOR. R may be same or different. Then poly means many esters will join, you remember. These are the polycondensation products. Here also something will come out, correct? Because it is also polycondensation products of dicarboxylic acid. Here what is required? Polyesters are the polycondensation products of dicarboxylic acids and diols. Diol means 2 OH will be there, correct? 2 OH will be there. Then here dacron or pterylene, that is the best known example of polyester. Okay, already I have discussed the reaction. Pterylene reaction I have discussed, dacron. Then here diol is ethylene glycol, diol, and dicarboxylic acid means now benzene 1,4-dicarboxylic acid. Then same things. This is also example of polyester, pterylene. These are the polycondensation products of dicarboxylic acids and diols. Dacron or pterylene is the best known example of polyester. It is manufactured by heating a mixture of ethylene glycol and terephthalic acid, or sometimes phthalic acid you can tell. Teri means 4 here. Terephthalic acid, temperature that is a 420 to 460 Kelvin in the presence of zinc acetate antimony trioxide catalyst. Okay, here what is required catalyst? Remember, zinc acetate antimony trioxide, SbO3, correct? Antimony, SbO3, and zinc oxide, zinc acetate, both is required here. Mixture of zinc acetate, antimony trioxide is used as catalyst. What I told reaction is the same. Dacron fibers means pterylene is a crease resistant, means it will not fold. Generally you require iron in your cloth, but here polyester it is not required iron. Iron is not required. Crease resistant and is used in blending with cotton. Sometimes polyesters are mixed with cotton. You might have seen when you might have gone to purchase the cloth, polyester, they will tell 60-40, 70-30, means 70% polyester, 30% cotton. It is mixed. Okay. Sometimes 80-20. Sometimes cotton will be more. 80 cotton and 20% this polyester. Then dacron fiber, also called pterylene, is a crease resistant and is used in blending with cotton and wool fibers, and also as a glass reinforcing materials in safety helmets. In helmets also, safety helmets, it is used. It is also used as glass reinforcing materials in safety helmets. Today I am stopping only here. Other polymers are there. I will discuss next class. Thank you.